Hello students, today our topic is Remainder Theorem. Now in this theorem we will learn how to find the remainder of the polynomial. In our previous session we learned what are polynomials, what are the different types of polynomial on the basis of degree, on the basis of number of terms, how to find the degree of the polynomial, how to find the zero of the polynomial. And today our topic is remainder theorem, and through this theorem we will learn how to find the remainder of the polynomial. Now let's check out this theorem. Let px be any polynomial of degree greater than or equal to 1. I hope this sentence is clear to you all. Px is a polynomial here, and this polynomial has degree greater than or equal to 1. And let a be any real number. Students, you all know what are real numbers. So here a is a real number. A is a real number means a is constant. If px is divided by the linear polynomial x minus a. So here in this case we are dividing px by x minus a. So we are dividing px by x minus a. Then the remainder is pa. So when we divide px by x minus a, your remainder is pa, right? So this is your remainder and your remainder, and your remainder is pa. So this is the theorem. Okay, this is called remainder theorem. Now let's prove this theorem. Now in division, if you are dividing 9 by 2, your division will be like this. Now in this division, what do we call 9 as? 9 is dividend. We call 9 as dividend because this is the number we are dividing. Okay, now we are dividing 9 by which number? 2. So this is called divisor. It is dividing, so this is called divisor. Now the answer which we got here, this is known as quotient. Okay, quotient. This is called quotient. Now whatever is left at the end of the division, this is known as remainder. It's not that you will always have 1 in the remainder. You may have 0, you may have any number. Okay, so this is called remainder. So similarly here, this is polynomial px, so this is dividend. Now x minus a is dividing px, right? Now this becomes divisor. Okay, now some answer will get here. Now that is known as quotient, so we'll replace it with q of x because quotient will get in term of polynomial. That's why I wrote qx. Now we'll get remainder here. We'll get some remainder here. It may be 0, it may be any other number, or it may be a polynomial. Okay, now the remainder is p of a, which is given in the statement itself. P of a, this is pa. Now see students, when we talk about the relationship between dividend, divisor, quotient and remainder, it goes like this. Dividend is equal to divisor, okay, into quotient plus remainder. Now 9 is equal to 2 4s are 8, 8 plus 1 is 9, so 9 is equal to 9. That is, this is the relationship between dividend, divisor, quotient and remainder. So same thing we'll use here. What is dividend here? Px. So this is px is equal to divisor x minus a. So x minus a. Now what is quotient here? What is quotient here? Qx, right? So quotient is Qx. So this is quotient plus remainder will be Rx. Is it clear? Now so students, in this case our polynomial will have degree 1 or it will have degree more than, greater than 1. That means the remainder will have degree less than 1 because remainders they are always less than divisors, isn't it? That means this remainder will have degree less than 1. Okay, if it has degree less than 1, that means r becomes constant. That's why instead of rx I wrote r here. Now after this, if x is equal to a, if we assume that x is equal to a, now p in place of x will write a is equal to In place of x, we are assuming a. So what is a minus a? It's 0, right? So 0 multiplied with any number is also 0. Now 0 plus r is r. That's why it's r here. That means to find the remainder of the polynomial, students, listen to me carefully. To find the remainder of the polynomial, we should replace the variable of the polynomial, okay? The variable of the polynomial with the constant number from divisor. So from this divisor x minus a is constant number, isn't it? Because a is a real number here. So a is constant number, and I have replaced x with a, and when I replaced x with a, we got the remainder. So this is called remainder theorem. I hope students you all understood what is remainder theorem. Now on the basis of this theorem, we have exercise 2.3. okay, exercise 2.3 is on the basis of remainder theorem. Now students, let's do exercise 2.3 from chapter 2, polynomials. Now first question, we have first question, that is question number 1, and your question number 1 goes like this: find the remainder. We have to find the remainder, as I have already told you. Find the remainder when this is our polynomial, when x cube plus 3x square plus 3x plus 1 is divided by what? X minus 1. That means in this question we have to find remainder. We have to find here, but we have to divide this polynomial by x plus 1, and we'll follow remainder theorem here. So by remainder theorem, so by remainder theorem, we'll write down the polynomial first, okay, px. Why x? Because here the variable of the polynomial is x. So we'll write px is equal to x cube plus 3x square plus 3x plus 1. This is our polynomial. And we have to divide this polynomial by x plus 1, isn't it, students? Now as I have already taught you in remainder theorem, that we have to replace this x with constant number from the divisor. So we'll find out the constant number here. X plus 1 is equal to 0. Now x is equal to plus 1. When we take it to the other side, this becomes minus 1. Okay, now we got the constant number. From divisor. This is divisor, right? So we got the constant number. So now we'll replace this constant number in this polynomial. Now p x, in place of x, what is the value here? Minus 1 is equal to, now x cube, what is the value of x? Minus 1, isn't it? We are just replacing x with minus 1, plus 3 x with minus 1, plus 3 x with minus 1, then plus 1. Okay, now this is minus 1 whole cube, means minus 1 how many times? 3 times. So minus 1 into minus 1 will gives us minus 1. I hope students you all know this calculation. Plus, okay, minus 1 whole square, minus minus are plus, 1 ones are 1, so 3 ones are 3. Now next, plus minus 3 ones are 3 plus 1. Now this will be equal to minus plus minus. So 3 minus 1 is 2. Greater number is 3. So plus will be here. Minus plus minus, right? So 3 minus 1 is 2. Now which one is greater? 3. And what is the sign of 3 here? Minus. Now what is 2 minus 2? 0. So here remainder is 0. Is it clear, students? This is how we find the remainder of the polynomial. Is it clear? So for the same question number 1, we have second part. So in second part we have x minus 1 by 2. Now it's same, okay, students? So you will write by remainder. So by remainder theorem, what is px here? Polynomial. This is x cube plus, 3x square plus 3x plus 1. Now let's find out the value of x from here. X minus 1 by 2 is equal to 0. Now x is equal to minus half. When we take it to the other side, this becomes 1 by 2. Is it clear, students? Now p, in place of x we have to replace with 1 by 2. In place of x, 1 by 2. In place of x, 1 by 2. Students, you all know the reason why we are replacing x with 1 by 2. Now 1 by 2 whole cube means this cube is meant for both 1 and 2. So what is 1 cube? 1. What is 2 cube? 8. Plus this is also meant for both 1 and 2. So what is 1 square? 1. What is 2 square? 4. So 3 ones are 3 and 4. Plus 3 ones are 3 and 2. Plus 1. Now I hope students you all know if we get the fractions, how do we solve it? We'll take the LCM of the denominators. Okay. Now let's take. Okay, I hope you all know how to find the LCM. So 2 2s are 4, 4 2s are 8. So 8 is LCM here. Now 1 multiply by 8 1s are 8 plus 3 multiply by 4 2s are 8 plus 3 multiply by 3 4s are 2 4s are 8 plus 1 multiply by 1 8s are 8, isn't it? Now this will become 1 times 1 is 1. 3 2s are 6. 3 4s are 12. 1 8s are 8 divided by 8. Now 1 plus 6 is 7. 7 plus 12 is 19. And 19 plus 8 is 27. Okay, so this is 27 by here. So here remainder is 27 by 8. Is it clear, students?